Hello. With this series of videos, I'm going to show you how you can use simultaneous equations in a DC circuit. And in the example I've got here, I've got a resistor network with a 220, a 330 and a 150 ohm resistor. And I've got two DC power supplies. Now I'll be using Kirchhoff's voltage law, which tells us that all the voltages in a loop, when you add them all up, will equal 0 volts. And then later on, I'll be using Kirchhoff's current law, which tells us that all the currents leaving and entering a node, the sum of them all equals 0 amps. So, like I say, this is it's an electronics problem, but the way to do it is by using simultaneous equations, so it's also maths. Now, it will take more space than I've got here to actually do it, so I'm going to spread this over several little videos. Okay, so firstly, we've got to decide which direction the current is going to flow. Now, as long as you stick to a convention all the way through, the answers will come out the same no matter which direction you decide that the current is going to flow. So I'm going to go and use these two as the directions of current flow. I'm going to form two equations. I'm going to say the current flowing around this one is for I1, and the current flowing around this one is for I2. So I'm going to start off using, well, I should have mentioned as well also, I'll be using Ohm's law. Voltage equals current I times resistance R. So the first equation I'm going to do is for this loop here. So I'll just call that equation 1. And the voltages across these two resistors will equal 20 volts according to Kirchhoff's voltage law. So the first equation is 20 equal to, now there'll be a voltage drop across this 220 ohm resistor. I don't know what the current is, but I can use Ohm's law and the resistor value to say what that current is. So it would be current I1 times resistance 220. So I'll say the first voltage drop is 220 I1. And then there's a voltage drop across here from this current. So again, 330 this time, I1. But I also have to take into account that there's a current coming through in this direction. Now, the way I've decided to draw the two loops, both currents are heading in this direction, so I'm going to add the current flowing in this direction from I2 using Ohm's law again. So the other voltage, which I'm going to take into account, is 330 I2. So that's the first equation. The second equation I'm going to create by using this loop here. So all the voltages in this loop must add up to 15 according to Kirchhoff's voltage law again. So 15 will equal, so voltage drop across the 150, so 150, but this one of course is I2. Voltage drop across this one, so I'm going to add to that 330 I2, and like we did here, I've got to take into consideration the voltage drop because of the current coming round in this direction, flowing through in the same direction with the convention I've gone with. So I'm going to add 330 I1. Now, I want to tidy these two equations up, so I'm going to add together these two I1s and these two I2s, and I'm also going to just place them in a different order. You'll see why in a second. So a new equation 3, so I'm taking this from equation 1, so the 20 doesn't change. I'm going to add, oh, I just realised that should have said 220, excuse me. So I'm going to add the 220 and the 330 because they're both I1. So that's 550 I1. And I'm also losing it here, 330 I2. And I'm going to create another equation from equation 2, so 15. Now I'm going to, because there's only one I1 here, and I want it to just line up with this, just to make it look neater, I'm going to put the 330 I1 in here first. And then I'm going to add the two I2s together. So 480 I2. Right, so I'm going to end this one here because, as you can see, I'm running out of room. I'll carry on with this in the next video, but I've got to the stage now where I've done all the sort of the electrical thinking and I'm left with two equations. So in the next video, we'll just concentrate on solving the simultaneous equation.